Welcome to the ninth session of this circular function series. In this session, we will apply properties of trigonometry functions, compound angle formula, sine rule, along with algebra formulas to solve circular function related problems through 9 worked examples.
Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything.
Welcome to the ninth session of this circular function series. Now the function given in example 1 is that y equals cosine x minus 3 all over the sum of cosine x and 3. The question is to find the range of this function. According to the rule of the function, we start to transform this function using the partial fraction technique. So the function becomes 1 minus the fraction of 6 over the sum of cosine x and 3. Since the value range of cosine x is between -1 and 1, including both endpoints, the minimum value of the function equals -2 when cosine x is -1, while the maximum value of the function equals -1 over 2 when cosine x is 1. Example 2 is to verify a trigonometry expression where alpha is in the first quadrant. To simplify this expression, Pythagorean identity relation is used to do this job. Based on the given expression, the denominator of every square root multiplies its conjugate accordingly. Then, after applying the Pythagorean identity relation, the expression is simplified to open bracket 1 minus sine alpha all over cosine alpha minus the fraction of 1 plus sine alpha all over cosine alpha close bracket multiplies open bracket 1 minus cosine alpha all over sine alpha minus the fraction of 1 plus cosine alpha all over sine alpha close bracket. Hence, the expression is simplified to -2 sine alpha over cosine alpha multiplies -2 cosine alpha over sine alpha, which equals 4. Example 3 is to find the domain and range of the function fx, which equals 1 plus arc cosine of 3x. According to the properties of the inverse cosine function, 3x is between -1 and 1, including both endpoints. Hence, x is between -1/3 and 1/3. Due to the range of arc cosine of 3x is between 0 and pi, including both endpoints, the minimum value of fx equals 1 when x equals 1/3. However, the maximum value of fx equals 1 plus pi when x equals -1/3. Example 4 is a question related to circle geometry. There are two circles C1 and C2. They intersect at points A and B. Circle C1 passes through the center O of circle C2. The point P lies on the circle C2, so that the line PAT is the tangent to circle C1 at the point A. The angle APB equals theta. There are 3 questions in example 4. Here we continue to work on example 4. Since the angle at the center of the circle C1 is twice the angle at the circumferences subtended by the same arc as shown in the diagram, the angle AOB equals 2 theta, which answered question 1. As for question 2, since the line PAT is the tangent line to the circle C1 at the point A, angle TAB is the angle between a tangent line and a chord drawn from the point A is equal to any angle in the alternate segment. Hence, the angle TAB equals angle AOB, which equals 2 theta. As for question 3, Since angle TAB equals 2 theta, angle ABP equals 2 theta minus theta, which equals theta. Hence, the triangle PAB is an isosceles triangle, so PA equals AB. The given criteria in example 5 are that the triangle ABC is an isosceles triangle with the angle ABC equals angle ACB. The line CL equals the line CM, and we assume that the angle CLM equals X. There are two questions follow. As for the first question, based on the given criteria that line CL equals the line CM and the angle ABC equals the angle ACB, the angle ABC equals 180 degrees minus 2x. As for question 2, since the angle BAC plus 2 times the angle ABC equals 180 degrees, the angle BAC equals 180 degrees minus 2 times 180 degrees minus 2x, or in parentheses, which is simplified to 4x minus 180 degrees. Hence, the angle TNL equals the angle BAC plus the angle ALN, which equals 4x minus 180 degrees plus 180 degrees minus x, which equals 3x as required. The diagram in example 6 shows that two triangles PQR and PRS are right angled at QR respectively. The angle QPR equals the angle RPS. The line PS equals 9 and 3 over 8 cm. The line PQ equals 2 and 2/3 cm. The question is to find the length of PR in cm. Based on the given criteria, in triangle PRS, cosine alpha equals PR over PS. In triangle PQR, cosine alpha equals PQ over PR. Hence, PR over PS equals PQ over PR. So, PR squared equals PS times PQ, which equals 25 after being simplified. Hence, PR equals square root 25, which equals 5 cm. There is the scaling triangle ABC in example 7. The three in angles A, B, and C form an arithmetic sequence. The ratio of the longest side to the shortest side is m. The question is to find the value range of this m. Since the three in angles of the triangle ABC form an arithmetic sequence, we assume angle C minus theta equals angle B, which equals the angle A plus theta. Due to angles A plus B plus C equals pi, 3B equals pi, so the angle B equals pi over 3. Since the triangle is a scalene triangle and the angles A, B, and C are expressed as pi over 3 minus theta, pi over 3, and pi over 3 plus theta accordingly. Two inequalities can be established then. Hence we have inequalities such as pi over 3 minus theta plus pi over 3 is greater than pi over 2. And pi over 3 plus pi over 3 plus theta is less than pi. After solving the simultaneous inequalities, theta is found in between pi over 6 and pi over 3. Alternatively, the value range of the angle theta can be obtained by solving the inequalities of pi over 2 is less than theta plus pi over 3, which is less than pi minus pi over 3. Based on the sine rule, m equals c over a, which equals sine c over sine a. Since the angle c equals pi over 3 plus theta, and the angle a equals pi over 3 minus theta, sine c over sine a equals sine pi over 3 plus theta over sine pi over 3 minus theta. Both numerator and denominator are then expanded using the sine addition formula. Here we continue to work on example 7. After expanding both numerator and denominator using the sine addition formula, m equals square root 3 plus tangent theta, or over the result of square root 3 minus tangent theta. So tangent theta can be expressed in terms of m, which equals square root 3 times the result of m minus 1 over the sum of m and 1. Since the angle theta is between pi over 6 and pi over 3, square root 3 times the result of m minus 1 over the sum of m and 1 is between square root 3 over 3 and square root 3. After solving the simultaneous inequalities, the value range of m is obtained, which is greater than 2. The criteria in triangle ABC in example 8 are cosine A equals 1/3 and its corresponding side A equals square root 3. The question is to find the maximum value of BC, where B and C are the lengths of the other two sides of the triangle ABC. Based on the sine rule, A over sine A equals B over sine B equals C over sine C, which equals 3 square root 6 over 4. So B equals 3 square root 6 over 4 times sine B, while C equals 3 square root 6 over 4 times sine C. Hence BC equals 27 over 8 times sine B sine C. According to the compound angle formula, sine B sine C is transformed to 1 over 2 times open bracket cosine B minus C minus cosine B plus C close bracket, which is further simplified to 1 over 2 times open bracket cosine B minus C plus cosine A close bracket after being simplified. Hence BC equals 27 over 16 times open bracket cosine B minus C plus cosine A close bracket. Here we continue to work on example 8. Since cosine A equals 1/3, BC equals 27 over 16 times open bracket cosine B minus C plus 1/3 close bracket. Hence the maximum value of BC equals 9 over 4 when angle B equals angle C. Alternatively, when we apply the cosine rule to tackle this question, since A squared equals B squared plus C squared minus 2BC times cosine A, 3 equals B squared plus C squared minus 2 over 3 times BC. Hence 3 is greater than or equal to 2BC minus 2 over 3 times BC. After solving this inequality, BC is less than or equal to 9 over 4. So the maximum value of BC equals 9 over 4. In example 10, there is a square inscribed in an isosceles triangle as seen in the diagram. The question is to find the length of the square A. According to the diagram, a line is drawn from the vertex C perpendicular to the triangle base AB and intersects AB at D. Because line GF is parallel to EQ, line CG is parallel to line FE. Triangle CFG is similar to triangle AEF. Based on Pythagorean theorem, CD equals square root of AC squared minus AD squared, which equals 8. Hence CG over FE equals GF over EA, since the ratio of the corresponding sides of two similar triangles is same. After substituting and expressing the lengths of these lines in terms of a, we have the equation of a minus a, all over a equals a over 2 over the result of 6 minus a over 2, which is simplified to a over the result of 12 minus a. After cross multiplying the fractional expression, we have the equation of a squared equals 8 minus a, all in parentheses, times 12 minus a, all in parentheses, which gives the result of a equals 24 over 5. If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.